A solid cylinder rolls down a smooth inclined plane 4.8 meter high without slipping. What is its linear speed at the foot of the plane if it starts rolling from the top of the plane? Now to solve this question we know V is equal to square root of 2gh upon 1 plus k square upon r square, which is equal to square root of 2 into 10 into 4.8 upon 1 plus r square upon 2r square, which is equal to square root of 96 into 2 by 3, which on solving we get 8 meter per second. So option D, 8 meter per second is the correct answer. A sphere of moment of inertia I rolls down a smooth inclined plane. The ratio of transitional kinetic energy to total kinetic energy is. So we know ETR, transitional kinetic energy upon total kinetic energy, is equal to half mv square upon half mv square. In bracket we have 1 plus k square upon r square, which is equal to 1 upon 1 plus 2 by 5, which is equal to 5 by 7. So option C, 5 by 7 is the correct answer. A thin circular ring rolls down a smooth inclined plane of inclination 30 degree without slipping. Its linear acceleration along plane is. Now to solve this question we know A is equal to g sine theta upon 1 plus k square upon r square, which is equal to g into 1 by 2 upon 1 plus r square upon r square, which comes down to g into 1 by 2 upon 2, which is equal to g by 4. So option D, g by 4 is the correct answer. A solid sphere rolls down smooth inclined plane of height h. If starts from rest, then the speed of the sphere when it reaches the bottom is given by. Now we know V is equal to square root of 2gh upon 1 plus k square upon r square, which is equal to square root of 2gh upon 1 plus 2 by 5 r square upon r square, which is equal to square root of 10gh upon 7. So option B, root of 10 by 7 gh is the correct answer. If the mass of the earth remains constant but the duration of the day reduces from 24 hours to 6 hours, then the relation between its new and the original radii r2 and r1 is given by. Now we know I1 omega 1 is equal to I2 omega 2 m r1 square 2 pi by t1 is equal to m r2 square 2 pi by t2, r1 square upon r2 square is equal to t1 upon t2, which is equal to 24 upon 6, which is equal to 4 upon 1. So r1 upon r2 is equal to 2. So r2 is equal to r1 upon 2. So option B, r2 is equal to r1 upon 2 is the correct answer. A disc of mass 4.8 kg and radius 1 meter is rolling on a horizontal surface without sliding with the angular velocity of 600 rotations per minute. What is the total kinetic energy of the disc? Now to calculate the total kinetic energy, we know total kinetic energy is equal to transitional kinetic energy plus rotational kinetic energy, which is equal to half mv square plus half I omega square. So I is equal to half mr square. Value for omega is equal to 600 rotations per minute, which is equal to 600 upon 60 into 2 pi radians per second, 20 pi radians per second. V is equal to r omega. So from this we can consider this to be equation number 1. From 1 we can say k is equal to half mr square omega square plus half mr square into omega square. which is equal to 3 by 4 mr square omega square, which is equal to 3 by 4 into 4.8 into 1 square into 400 pi square, which on solving we get 1440 pi square joules. So option A, 1440 pi square joule is the correct answer. A meter scale of mass m is standing vertically on a horizontal table on one of its end. It's now on the table without slipping. It's now falling on the wall without slipping. The velocity with which the free end of the meter scale strikes the table is. So now to solve this question we know h is equal to 1 by 2 meter, L is equal to 1 meter, loss of potential energy is equal to gain of kinetic energy. So mgh is equal to half I omega square, which is equal to half into ml square upon 3 into omega square. So g into 1 by 2 is equal to omega square by 3 into 1 by 2. So omega square is equal to 3g. Omega is equal to square root of 3 into g. V is equal to L into omega. L is 1 and this is square root of 3 into 10, which is equal to square root of 30 meter per second. So option C, square root of 30 meter per second is the correct answer. A disc of mass 2 kg is rolling on horizontal surface without slipping with velocity of 0.1 meter per second. The total kinetic energy of the rolling disc is. Now to solve this question we know total kinetic energy is equal to half mv square plus 1 by 4 mv square, which is equal to 3 by 4 mv square, which is equal to 3 by 4 into mass is 2 kg, so 2 into velocity is 0.1, so 10 raised to minus 2, which is equal to 1.5 into 10 raised to minus 2 joules. So option C, 1.5 to 10 raised to minus 2 joules is the correct answer. A body is rolling down an inclined plane if the rotational kinetic energy of the body is 40% of its translational kinetic energy. Then the body is a. Now to solve this question we know half I omega square is equal to 4 by 10 into 1 by 2 mv square. So half mk square into v square by r square, which is equal to 2 by 5 mv square. So k square is equal to 2 by 5 r square. So therefore it is a solid sphere. So option C, solid sphere is the correct answer. A solid sphere is rotating about diameter at angular velocity omega. It is kept in an extremely cold surrounding so that the radius shrinks 1 by nth of the original radius. What will be the new angular velocity? Now to calculate the new angular velocity, we know that to solve this question, moment of inertia of a solid sphere is 2 by 5 mr square. As no external torque is acting onto the sphere, its angular momentum is conserved. So I can write L1 is equal to L2, I1 omega 1 is equal to I2 omega 2, 2 by 5 m r square omega 1 is equal to 2 by 5 m r by n square omega 2. As we know, R2 is equal to r by n. So omega 2 is equal to n square omega 1 or n square omega. So option A, n square omega is the correct answer. The angular speed of the body changes from omega 1 to omega 2 without applying torque. But due to changes in the moment of inertia, what is the ratio of radius of gyration in two cases? So now to solve this question, we know if the torque is not applied, then by using the principle of conservation of angular momentum, I1 omega 1 is equal to I2 omega 2, but I is equal to mk square. So m k1 square omega 1 is equal to m k2 square omega 2. K1 upon K2 square, K1 square upon K2 square is equal to omega 2 upon omega 1, or K1 upon K2 is equal to square root of omega 2 upon omega 1. So option A is square root of omega 2 upon omega 1 is the correct answer. A particle with position vector r has linear momentum p bar. Which of the following statement is true in respect of its angular momentum L about the origin? Option A, L acts along R. Option B, L acts along P. Option C, L is maximum when P bar and R bar are parallel. D, L is maximum when P bar is perpendicular to R bar. Now to solve this question, we know that angular momentum L bar is equal to R cross P. So L is equal to RP sine theta. So we know theta is equal to 90 degree. If theta is equal to 90 degree, R is perpendicular to P. So L is equal to RP sine 90, which is equal to RP. So thus R cross P is maximum when P is perpendicular to R. So R cross P is maximum when P bar is perpendicular to R bar. So option D, L is maximum when P bar is perpendicular to R bar, is the correct answer. Two bodies have the moment of inertia I and 2I respectively about the axis of rotation. If the kinetic energy of the rotational are equal, then the ratio of their angular momentum will be. Now to solve this question, we know that half I1 omega 1 square is equal to half 2I omega 2 square, given omega 1 upon omega 2 is equal to square root of 2. So L1 upon L2 is equal to I1 omega 1 upon I2 omega 2, which is equal to 1 by 2 into square root of 2, which is equal to 1 upon root 2. So option D, 1:root 2 is the correct answer. A ballet dancer revolved at 24 rpm with her hands folded. If she stretches her hands so that her moment of inertia increases by 20%, then the new frequency of rotation will be. Now to solve this question, we know by principle of conservation of angular momentum, I1 omega 1 is equal to I2 omega 2. So I1 into 2 pi n1 is equal to 12 by 10 I1 2 pi n2. So n1 is equal to 12 upon 10 times n2, which is equal to 6 by 5 times n2. So n2 can be written as 5 by 6 times n1. So 5 by 6 into value for n1, 24 upon 60, which is equal to 1 by 3. So number of revolutions per minute is equal to 1 by 3 into 60, which is equal to 20 rpm. So option B, 20 rpm is the correct answer. A uniform meter scale of mass 0.2 kg is rotated upon axis, passing through its one end and perpendicular to its length at the rate of 60 revolutions per minute. What is its angular momentum? Now to solve this question, we know that in a meter scale, for the meter scale, I is equal to ml square upon 3, which is equal to 0.2 into 1 square upon 3, 1 upon 15 kg meter square, and omega is equal to 2 pi n. So that is 2 pi into value for n is 1, which is equal to 2 pi radians per second. Angular momentum is equal to I omega, which is equal to 1 by 15 into 2 pi. So that can be written as 2 pi upon 15 kilometer square per second. So option A, 2 pi upon 15 kg meter square per second is the correct answer. The position vector of a particle in space is given by r is equal to I plus 2j minus k and linear momentum p is equal to 3i plus 4j minus 2k. Then the angular momentum is perpendicular to. Now to solve this question we know L is equal to r cross p. So L is equal to I cap j cap k cap upon 1 2 minus 1 values for r, then p, that is 3 4 minus 2. On solving what we get is I cap into minus 4 plus 4 minus j into minus 2 plus 3 plus k into 4 minus 6, which is equal to 0 minus j minus 2k, which is equal to minus j minus 2k. Since the angular momentum does not have x component, it is perpendicular to x axis. So option A, x axis, is the correct answer. The position vector of a particle of mass 10 gram above the origin is 4i plus 3j meter. If it moves with a linear velocity of 4i meter per second, then its angular momentum will be. Now to solve this question we know L is equal to r cross p, m r cross v, 10 into 10 raised to minus 3, 4i plus 3j into 4i, which is equal to 10 raised to minus 2 minus 12 k, which is equal to 0.12 minus 0.12. So option B, minus 0.12 k Js joule second, is the correct answer. A solid cylinder of mass 10 kg and radius 20 cm is free to rotate about its axis. It receives an angular impulse of 4 kg meter square radians per second. What is the angular speed of the cylinder if the cylinder is initially at rest? Now to solve this question we know that for a cylinder I is equal to mr square upon 2, which is equal to 10 by 2 into 2 by 10 into 2 by 10, which is equal to 0.2 kg meter square. Linear impulse is equal to f dt in rotational motion. F dt, linear impulse, is equal to f dt. So angular impulse is equal to tau dt, torque into dt. That is, value for torque is I alpha into dt, which is equal to I into, value for alpha is d omega by dt into dt. So dt gets cancelled. We are left with I into d omega. So angular impulse. So d omega is equal to angular impulse upon I, which is equal to 4 upon 0.2, which is equal to 20 radians per second. 20 radians per second. So option A, 20 radians per second, is the correct answer. A circular disc of radius r and thickness r by 6 has moment of inertia I about an axis passing through its center and perpendicular to its plane. It is melted and recast into a solid sphere. What is the moment of inertia of the solid sphere about its diameter as axis of rotation? Now to solve this question we know that since mass and density have not changed, volume of the disc is equal to volume of the sphere. Volume of disc is equal to volume of sphere. So pi r square h is equal to pi r square into r by 6, which is equal to 4 by 3 pi r cube. Where r is the radius of the sphere, r cube is equal to r cube by 6 into 3 by 4, which is equal to r cube by 8. Therefore, r is equal to capital R by 2. Moment of inertia I is equal to mr square by 2 So moment of inertia I dash for the sphere I dash will be equal to 2 by 5 m r square, which is equal to 2 by 5 m into r by 2 square, which is equal to 2 by 5 m r square by 4. Therefore I dash can be now written as 1 by 5 into 1 by 2 m r square, which is equal to I by 5. So option D, I by 5 is the correct answer. The moment of inertia of uniform rod about a perpendicular axis passing through one of its end is I1. The same rod is bent into a ring and its moment of inertia about the diameter is I2, then I1 upon I2 is. Now to solve this question we know for a rod of mass m and length L, the moment of inertia about perpendicular axis passing through one end is I1, which is equal to ml square upon 3. Value for L is equal to 2 pi r. R can be also written as L upon 2 pi. Therefore, the moment of inertia of ring about its diameter is given by I2, which is mr2 r square upon 2, which is equal to m upon 4 pi square L square upon 2, which is equal to ml square upon 8 pi square. Therefore, I1 upon I2 is equal to ml square upon 3 into 8 pi square upon ml square. So ml square and ml square gets cancelled. We are left with 8 upon 3 pi square. So 8 pi square upon 3, option C, is the correct answer. The ratio of radii of gyration of a circular ring of a same radius above the tangential axis in the plane of the disc and the ring is. Now to solve this question we know I of disc, that is moment of inertia of disc, is equal to pi by 4 mr square, which is equal to m k1 square. Value for k1 is equal to square root of 5 upon 2 r. I of ring is equal to 3 by 2 mr square. So m k2 square is equal to 3 by 2 mr square. Therefore k2 can be written as square root of 3 by 2 r. So k1 upon k2 is equal to square root of 5 upon square root of 6. So option D, square root of 5 upon square root of 6, is the correct answer. The radius of gyration of a body about an axis at distance of 6 cm from the center of mass is 10 cm. What is the radius of gyration about a parallel axis through its center of mass? Now to solve this question, we know that according to parallel axis theorem, I0 is equal to IC plus mh square. So mk square is equal to mk square plus mh square. K square is equal to, or k dash square can be written, k dash square is equal to k square plus h square. Substituting the values, which is equal to 10 square is equal to k square plus 6 square. Value for k square can be now written as plus 6 square will go this side and become minus. So that is 10 square minus 6 square, which is equal to 64. So value for k is equal to 8. So option D, k is equal to 8 centimeter, is the correct answer. A sphere is rolling on a horizontal surface without slipping. The ratio of its rotational kinetic energy to total kinetic energy of sphere is. Now for sphere we know rotational kinetic energy. Rotational kinetic energy is equal to 1 by 2 I omega square. That is 1 by 2 into 2 by 5 mr square into v square by r square, which is equal to 1 by 5 mv square. Therefore, rotational kinetic energy upon total kinetic energy is given by half I omega square upon half mv square plus half I omega square, which is equivalent to 2 by 7, or which is equal to 2 by 7. So option B, 2 by 7, is the correct answer. What is the ratio of radii of gyration of a circular disc to that of circular ring, each of the same mass and radius around their respective axis? So now we know for circular disc, ID will be mr square upon 2, which is equal to mk square. So kd square is equal to r square upon 2. For circular ring, IR is equal to MR square, which is equal to MK square. So KR square is equal to R square. So now KD upon KR is equal to square root of R square upon 2 into 1 upon R square, which is equal to 1 upon root 2. 1 is to root 2. So option C, 1 is to root 2 is the correct answer. Two circular rings A and B of radii NR and R are made from the same wire. The moment of inertia of A about an axis passing through the center and perpendicular to the plane of A is 27 times that of smaller loop B. What is the value of N if the length of A is equal to N times length of B? Now to solve this question, we know that for A, RA is equal to NR. For B, RB is equal to R. Length of A is equal to N times length of B. Since the wires are of same material, mass of A is equal to N times mass of B. So IA is equal to MARA square, which is equal to N into MB into NR square. That can be now written as N cube MB R square, which is equal to N cube IB. So IA upon IB is equal to N cube, which is equal to 27. So value for N is equal to 3. So option B, 3 is the correct answer.